Hello Internet and fellow network engineers. My name is Maxim and I share network tips and tricks with you on my channel. Today, the topic of our conversation is Internet of Things or IoT. Your robot vacuum, your smart camera, or the LED strip in the back of your TV. The smart devices make our life easier and brighter, but they also bring risks to our network and to our lives. Today, in the series of 3 videos, we'll cover risks and how we can mitigate them. I will share my own design solution with you, how I protect my own network and how you can protect yours. We'll do a theory block and also we'll do a lab exercise. And for lab exercise, we'll use a Juniper SRX series firewall. We'll use Juniper Mist AI wireless solution. And we'll use this little guy, the Raspberry Pi Zero. Excited? Buckle up and let's get going. So let's start with the theory. We'll start with covering risks. Each IoT device is a small computer which has its own operating system and services. These operating systems can have vulnerabilities as well as the services like any computer. There can be lack or delay release of patches, fixes coming from the manufacturer. You cannot update those yourself, right? You always rely on the manufacturer and their IT team. There can be ports left open, unnecessary services running. They can be answering like ping or some other unexpected traffic by themselves. So as any rapidly developing niche of products, smart products are often come and go, always new products released. So there is like a race between different vendors and manufacturers. Because of that, vendors often abandon certain products which they released quite recently. Because of that, there can be either a delay or complete stop of releasing new security patches or new features. Some vendors may even start charging subscription fees to make sure that you are using the, let's say, the latest and greatest, right? We just need to keep it in mind. Next, there are products from questionable or unknown manufacturers to the market. You may get a gift for your birthday of smart products which you've never heard about, right? And especially for the newcomers, especially for the startups, often they are just focusing on the design and marketing, but they forget about the proper securing and hardening of their software. Another thing is that their IT resources and their cloud can be overseas and cannot be subject to US laws and regulations. When you enroll a new device in your IoT smart home, you put your PSK or pre-shared key, the key to your wireless LAN, in the app, so in effectively sharing this key to a third party, to the vendor, right? And then often this key is being stored and saved by the cloud and by the manufacturer. And again, you never know how this key is handled and how it is being used. Then there is a privacy concerns of storage of video and audio data from the security cameras. Sometimes they're stored in the cloud. There is potential unauthorized access to this footage and even live view, which we've seen in the news, which can be terrifying. There can be lack of commitment to data security or privacy. Your video data can be used to train neural networks, being shared with marketing advertisers, etc. Next, any IoT device being infected can act as a landing site or a backdoor to do the reconnaissance and attacks to your network devices, as well as attacking internet devices from your public IP address. And finally, this is the best perfect fit for the botnet, right? The botnet is basically a large networks of the infected devices which are being orchestrated from a CNC or command and control server of the botnet. Again, why? Because there is no antivirus software, there are no protection software for the IoT devices. They are always on and connected to the internet, and there is large scale of similar vulnerabilities, because usually there are like millions probably of the similar devices with a similar software and similar vulnerability because of that. And also there is a way to potentially infect large scale if you get to the cloud itself or to the management channel itself. So today I'm presenting you my security solution, which I use at home. I use it for my network, and I believe it is quite good to share it with you. And besides effectiveness, right, I can say that there are 4 different requirements which I believe are important, especially for the home network or for the small business network, for like warehouse type of scenario, etc. There are low cost, low power consumption, low maintenance, and beginner engineer friendly. The logic which I introduce in this process is the next. First, we'll start with segmentation, segmenting our network. Next, we'll go and do the isolation. The step number 3 will be filtering. And there is also optional step 4, which I call advanced tactics, but again, it is optional, right? So it can be skipped if it is unnecessary. And this process is a loop. So as soon as we complete it, we are going back to square one, and we keep going again and again until we are satisfied with the state of our network. Now, it's time to set some scope and boundaries for this video and for this design. Again, the IoT world is huge, right? There are different type of devices, different protocols, different types of connection, and we can usually separate multiple areas, major areas. It can be, again, as we go from the top to bottom, it can be a device connected to a Wi-Fi. It can be a Wi-Fi speaking smart plug or smart bulb. It is connected to directly to your wireless network. It has a Wi-Fi chip on board, right? So this is option 1. There is option 2, where you have devices which are being connected to a hub. So the hub in this case is basically an intermediary between your network talking over Wi-Fi to your router. It has an IP address, it has a Wi-Fi chip inside, and on the other side it is communicating to other devices, usually smaller, usually battery powered, but it depends. And then these devices are usually communicating to a hub using a different type of protocol, not Wi-Fi, because the Wi-Fi is power hungry. It can be, again, Bluetooth, BLE, Zigbee, Z-Wave, Thread, or it can be even something proprietary. And also in the bottom we can see a very similar type of scenarios, but we're using the Ethernet wired connection, right? It can be, again, an IoT directly connected, or it can be a hub. Focus for our video will be only the device connected to the network, right? We won't touch other devices which are using other methods connected to the hub. The hub will be our boundary in this specific use case. Again, on the right side you can see examples of in-scope devices. They can be like smart bulbs, your smart vacuum cleaner, robot vacuum cleaner. It can be like air quality monitor, smart cameras, smart appliances, etc. And these all devices which are in scope of this video and in scope of this approach are devices without horizontal connections, or east-west as we call them, when one device on your network needs to communicate to another device on your network. Focus of our video is device that is only communicating to the cloud, to its management server. It doesn't require any horizontal connections. There are out-of-scope examples, which we again don't cover with this video, and probably I will create another video for them in the future. Again, a great example is network printer, right? It requires for your devices to communicate to it over the network. It can be Apple HomeKit devices because they heavily rely on east-west communication. Or a multimedia speaker, like devices like Wi-Fi speaker or an AirPlay smart TV. Right? These are out of scope, so we'll cover the rest. And also the potential risks and vulnerabilities of the wireless channel itself are also out of scope of this video. So we'll not touch this. We'll not touch WPA2, WPA3, key length or something like this, right? We'll just focus on the network portion. So let's look at our square one. This is a sample of the network, which you can see, again, probably at your home. It's just a single VLAN and single SSID where you connect your laptop and then you connect your smart LED lights on the back of your TV and probably your doorbell and then probably your NAS where you store your tax returns, right, and your private documents and your pictures, all in one network. So let's have a look how we can make it better. So we'll start with segmentation, step one, and we'll look at the challenge. So in this challenge, we have a laptop on the left side which is infected. Again, it can be an infected USB stick, it can be a phishing link, or a malware infection. Right? So as soon as this happens, again, modern malware is different from the malware back in the days where it used to announce that, hey, I'm here. Modern malware is hidden. It keeps silence. It doesn't show itself. But the idea is that, again, if the device is infected, it will try to spread the infection, right? And because of our unfortunate network situation, it will be able to reach every device on the network, right? Another thing which we can point here is that you can notice that our IoT devices, again, they don't have any antivirus. They have no protection at all. And also your NAS, for example, is exposed potentially in this type of scenario. There is challenge B. Let's look at our IoT device in the bottom which got infected. And again, there are multiple ways how it can get infected. There can be a compromised firmware update coming from the cloud. Again, we've seen it with certain products before. It can be a man-in-the-middle attack with a control channel hijacking or cookie stealing. Again, depending on what channel vendor is using, is it encrypted, not encrypted, weak method, etc. It can be, again, a botnet type of infection. And if your device is infected, again, the whole idea is that it will try to scan your network. It will try to spread the infection, find the weakness, right? And again, it is able to reach anything in your network. Your firewall, despite present, cannot protect from it in this scenario. Let's start with the first part of the solution. So the first part of the solution is segmentation. So what we can do, we can create a dedicated VLAN for IoT. We can create a dedicated security zone for IoT. We can create a dedicated WLAN SSID for IoT devices. In this case, we completely harbor our important devices like our laptop and our NAS in completely different network from our IoT devices. In this case, infected IoT wall switch on the left side is not able to reach our NAS or laptop anymore, right? So we are one step ahead. Let's look at our step 2 in our challenge. As I mentioned before, we always trust our PS key to the vendor and store it in their cloud. potentially this key can be compromised. It can be leaked. And what can be even worse, together with your public IP address, it has an opportunity to geolocate you and your house, your location. And again, in this diagram, there is a potential situation where there's someone who has a key to your network, right? And who can like drive by, stop by, and connect to your network and get access to your devices. So let's have a look what we can do. There is a nice feature which is called multiple PSKs for the wireless network. So by doing that, we can, this is what, for example, I do, right? We can create a dedicated key for the same SSID for each vendor you are using at your home, right? You can use vendor 1, 2, and 3 devices, and you can create a separate key for each vendor. In this case, you do still share it to the cloud, but you share different key to different vendor, right? And potentially, again, if the leak or compromisation happens, it will happen only to a single key, not to all of them, right? It's like having multiple keys from different locks in your house. Again, so potentially there is also there is a way to for anybody, like potential ways to connect to your network, but we will go further in our process and find out how we can decrease the chance of that, right? And again, a couple more notes here. What is great about this approach and what I really like is it is recommended to periodically change your key, let's say once in a year. In my home, I have close to 100 IoT devices, and it becomes a daytime job to change the key on every single device. It's hard. And in my case, again, I use multiple keys for my devices, and then when I decide it's time to change the key, I change one vendor at a time. In this case, I save time, and I'm going forward to my goal for a key rotation. Otherwise, again, it used to be a single key, and as soon as I change the key on the wireless access point, all my devices are down. And then I fix them one by one, and then likely I need to do something else, right? I don't have enough spare time to do it, and it means half of my devices will be down for a day or two, right? Which is inconvenient. So this is great. With this specific use case, you can create a key first, new key, and then migrate your devices one by one from old key to the new key completely without downtime, right? So this is something quite interesting. Let's go next. And now we are going to the isolation part. So let's look at our challenge. Again, it is very similar to what we've seen before, so we're still at that point, right? Again, every single wireless device in our IoT can reach other devices, right? It means it requires just a single weak link, just a single weak device to get your network exposed, right? So, but there is a solution. So let's look at the bottom. There is a feature called client isolation, available for the Mist APs. And what it does, it creates a rule on the AP which can prevent devices communicating to each other in the scope of a single AP or in the scope of the whole VLAN. It means that if devices on the left would like to communicate to the network, they can communicate only to their gateway, which is the firewall, right? So now the switch on the left side is not able to communicate to any other IoT devices, including wired client connected. But it can still communicate to the firewall and go to the internet without any problem. Additional thing which I'm doing here is restricting ARP and restricting bump traffic over the wireless network, which can increase your efficiency and basically efficient utilization of the wireless spectrum. And there is also an optional state, which we'll cover in using a few next slides. But optionally, client isolation can also be done on the SRX itself using a special mode called transparent bridge mode, or using a dedicated switch like Juniper EX using private VLAN or firewall filtering for the Ethernet switching. So let's a little bit look closer. Again, imagine that you have wired clients, not only wireless IoT devices, but you have also wired IoT devices. It can be wired sensors. It can be something else. Again, it doesn't matter. And let's have a look how this specific Juniper branch series SRX is working. You have a diagram on the left side. So wired IoT device is able to communicate to another wired IoT device in the default mode, which is called switching mode. In this case, even if you have a restrictive rule on your firewall, these devices can still communicate to each other. You may ask why, and so let's cover it. So internally, the Juniper SRX branch series architecture look like this. We have a layer 2 switch ASIC, and then we have a FlowD process above it, right, where we do all the firewall route lookup and all the stateful firewall features. Again, in the default mode. In this case, wired devices can communicate to each other. They don't need to go to FlowDaemon because they just communicating inside the same network. And in the switching mode, there is no way how you can restrict it. So you can restrict traffic going outside of the subnet. This is where we have our security zone on the FlowD, but not inside the VLAN. Again, optionally, we can use something called transparent bridge mode, which creates an opportunity to use security zones for the layer 2 interfaces instead of layer 3 interfaces, right? In this case, we can do the wired client-to-client isolation, but this mode is even more interesting than this. So there I will be doing dedicated video just for transparent bridge and wired client isolation in the future. And again, as I mentioned before, there is also an opportunity to use a dedicated switch connected to the SRX. Like you can have more devices connected to it, right? Plus, you can utilize security features of the Juniper EX switch, which in combination can give you better results. And this is, again, just a couple options which we can use on Juniper EX switch. We can use private VLANs. In this case, again, it's powered by EX. On EX, we can configure something called isolated VLAN. This is by placing different devices and different ports inside that VLAN, you restrict them to communicate to each other, while your upstream is called a promiscuous interface, where all the traffic is going up to the SRX, to the firewall. Or alternatively, we can do a firewall filtering for the family Ethernet switching on the layer 2 interfaces by allowing only broadcast and traffic going to the IRB, SRX IRB or SRX MAC address, right? In this case, wired devices will be able to reach the SRX, but not each other, because you will just drop it using the firewall filter. So this is security features what Juniper EX switch or switch can provide to us. And again, a few examples of where this specific thing may be useful. It can be, again, probably you have substantial amount of wired IoT devices. Again, it can be like a warehouse scenario where you have a lot of like terminals, etc., like sensors, commercial sensors, etc. It can be server ILO. You may have a server farm, dozens of servers with the ILO. It makes sense to isolate them from each other. Again, from the security perspective, ILO on the server does not need to communicate to another ILO on another server unless it is infected, right? So again, a good use case. Or you have a high security requirements and you would like to harden anything which is not needed. And now we are going to our step 3, which is filtering. And this is our challenge. Usually this is how it works, right? Your client, your IoT device, does a DNS request to something like redirecttest.com. It gets a response for the addresses it is associated with. And then it generates outgoing traffic, right? So basically one of these addresses. And then the traffic is going through our firewall, through our SRX, where we do enforcement. Okay, we do allow. And for something like ccmalware.com, we block, right? But the idea is that firewall is doing it using 5-tuple security policy approach by verifying 5 parameters like source address, destination address, protocol, source port, destination port. It's very hard to maintain because, again, redirect.test.com can go to one address, redirect2.test.com can go to other addresses. It can be cumbersome to maintain your security policies and your address sets for the efficient work. So this is an example. Let's say you have an IoT device, and again, either based on your research, which can be quite challenging, or based on the documentation, you found out that these are the 4 URLs it is using, right, for its complete operation. In this case, you start configuring your firewall rules for these addresses, which, again, this is cloud, right? The cloud is very agile. New features are being added. The process chain may change, right? These URLs can be different tomorrow. And again, you will need to do like a race trying to catch to them. But there is an alternative which we can use and which we will use in my solution. And this is DNS filtering. Just imagine that you can not allow URL by URL, but you can actually use wildcards and allow anything from that URL. Would it sound nice, right? And this is the example. Just imagine that, again, your IoT device goes to redirecttest.com based on that rule, right, on the previous page. It opens TCP connection and your firewall is allowing it. You can notice there is no enforcement sign on the firewall because firewall in this case just wide open. And if the device is using some request to a malware.com, what happens? Your DNS server returns zeros as a response. And then there is no outgoing traffic because zeros is an invalid address. You don't even need to do any enforcement on the firewall because the traffic doesn't go out to the firewall. How does that sound? And the approach which we are using is called whitelist approach, where we drop everything by default, but we allow certain domains and wildcard domains purposely for different type of our devices. And we'll be using the Pi-hole software for that today. So this is an awesome product. It is free to use. It's powered by donation. There is a link here and link in the description to their webpage. They have exceptional GUI. They always add new features. It even runs on Raspberry Pi, so it doesn't require anything extra or super powerful hardware. So even that small Raspberry Pi Zero, which we'll be using today, can handle it. And the screenshot, this is a nice example from my lab. Okay, so this is our solution. So how we can use it, right? So in this case, you can notice that now we have a DMZ zone where we place our Pi-hole server. And then we just change our DHCP server for IoT devices to send a different name server. And now the DNS server provided by the DHCP is actually Pi-hole. And now all our wireless and wired IoT devices, they go to the Pi-hole for the DNS requests. And if they would like to bypass that and go directly to the internet, we'll explicitly drop it. So, and then the Pi-hole will be covering the whitelisting approach for the DNS for our IoT devices with a detailed logging for the analysis. Doesn't it sound sweet? Okay, and then next we have step 2. So in our filtering solution, we'll be doing also another step. Again, I'm a fan of zero trust approach, and according to this approach, we have to allow only traffic which is absolutely necessary to allow. It always starts with host and bound traffic, which shows what traffic from each security zone can come to the SRX, Juniper SRX itself. For example, from untrust, usually nothing should be coming to the SRX itself, except DHCP if you have a dynamic address to web provider. For the IoT, we'll allow only DHCP because we provide DHCP server functionality to that VLAN. For the DMZ, we'll provide ping and DHCP. Again, I usually prefer to keep a small pool, DHCP pool for the DMZ, just for initial bringing up devices before I assign static address. And the trust zone, where I will allow DHCP, because again we are DHCP server, ping, traceroute, and SSH. So this is the way how we'll manage it from our laptop, the SRX itself. Next step is always security policies. So now we'll need to set what traffic can go from what security zone to what security zone. And again, let's start from top left. From the IoT zone, we can go to the untrust. Again, I put here any, but I mentioned before that I explicitly drop any DNS, TCP or UDP going directly to the internet. So all DNS should be handled by the Pi-hole only. IoT cannot go to trust, as we mentioned before, segmentation. And IoT can go to DMZ for the DNS services, right? And the ping is optional. Next, let's look on the right side. Untrust cannot go to anywhere, right? Because we keep our untrust zone separated. No traffic can be initiated from that zone toward the internals. Let's look at the DMZ. The DMZ can go to the untrust. It needs to get the DNS information. It needs to do updates for like software, right? Updates like filtering lists if you use any. But DMZ should not be able to go to IoT or trust. It doesn't need it. And finally, trust can go to untrust. Again, we are just not limiting it. Again, it's up to you, so it's always a matter of preference. But also look at that. Trust should not be able to go to IoT, because again, all IoT devices are managed by cloud. So if trust doesn't need to go to IoT, there is no point. And it basically, again, means that if you have a laptop in the trust zone which is infected, it won't be able to reach to your IoT devices and infect them further, right? So this is an approach for the zero trust mentality. But also trust needs to go to DMZ using SSH and HTTP for the Pi-hole management. Let's return back to the process logic, and again, this is a summary slide you can go through. So what I would like here to mention is the advanced tactics, as I mentioned before, which is optional step, right? We won't cover advanced tactics in our lab block for this video, but it's worth mentioning. Again, this is something like extra mile you can go if you wish. Remember that we are filtering IoT traffic using DNS. Right? But remember that we are using DNS, but we don't use our firewall for that. So we rely on the DNS. And the majority of the traffic are using DNS first and then go to the internet, because again, this is how you can get the best results. But you can get a malware or infection which is going directly to the IP address. Right? In this case, you don't need to have a DNS server request. It can go straight to that IP address, fixed IP address. Again, it's not scalable. Even modern malware is like an enterprise software. It also has like load balancers, server farms, cloud, etc. But still, there is also an optional possibility for you to keep the firewall in place to do the filtering based on, let's say, your information you collected from the Pi-hole, you can create rules on your firewalls based on them, even in an automated way by parsing the logs on the Pi-hole. Again, it's harder to do, and it is again higher maintenance, which I would like to avoid. So that's why I don't recommend it in the base approach. Next, unique whitelists per IoT vendor. You are welcome to do that. All right, so you can create different lists for different type of devices, etc. You can go granular. Again, if you wish, you can do rate limiting of IoT devices. For example, you have like smart plugs, you have like light bulbs. They don't consume much traffic usually, but again, you can enforce some protective measures to make sure that they don't, let's say, go above certain threshold. You can log your sessions on the firewall for different devices using a dedicated log file. You can create Pi-hole server redundancy. This is something what I would recommend. There are different cases which you can store your device in. You can purchase couple Raspberry Pis. I would recommend Raspberry Pi 02. So this is a faster version. So this is what I have in production. In the lab module, we'll be using the older version, like just Pi-hole 0W. But again, it's perfectly capable. If you have two, you can always send two DNS servers to your IoT devices, and if one of your devices is in down state, it will go to another one, so you get redundancy. There is an optional thing which is SSL decryption for the IoT traffic on the firewall, but again, usually it is not good fit for the IoT. Because IoT frequently rely on certificate based, and as soon as you try to break it in the middle, you may have complete outage. But again, it's probably an overkill. But just mentioning. Next approach is DNS over HTTPS or DOH. So this is something that device can try to bypass Pi-hole by going directly to a DOH server in the internet using TCP 443 in an encrypted way. So you won't be able to look inside. But again, it's an effective way to bypass the regular clear text DNS. Again, you may consider an option to create a dynamic prefix list to drop different DOH servers in the internet. By doing that, you basically restrict that possibility to bypass your Pi-hole. And final thing is App ID or application firewall, which you can use on SRX, but this is a licensed feature. But yeah, in addition, you can analyze like what kind of data, what kind of protocols your IoT devices are using, and then based on your collected knowledge, you can introduce some application firewall rules. So this is again optional stuff. And as I mentioned before, remember this is a looped process. Why? Right? So let's say we went through segmentation, isolation, and filtering for our example, but remember we have a NAS server, right? The NAS in our network. Just imagine that, again, if your laptop is infected, it can directly go to your NAS, right? In this case, you can go back to your segmentation step and think like, is my information on my NAS that critical to place it in a dedicated security zone, right? And then create a different firewall security policies to it, just to make sure that, again, let's say laptop can go there using only one single SSL port, right? Without being able to connect to anything else. It's a good option, right? So let's go next. Again, we will go back to square one. This is the solution. It had 4 requirements which I put initially in it. Low cost. So we are in this specific demo which I'll be showing you. We use Juniper SRX based software features only, which don't require any additional licenses. The Pi-hole itself is a free-to-use product powered by the nations. The only one exclusion is Juniper Mist Wi-Fi requires subscription. So the AP which I'll be showing you today It requires subscription, but it can be purchased from Juniper reseller or a partner. Low power consumption. Juniper SRX, Raspberry Pi and AP, together they consume 38.8 watts average, and they are zero noise and with passive cooling. So they are like user-friendly or home-friendly. Low maintenance. Required initial involvement when you create your whitelists, and then only periodic checks are required to either revise your whitelist or add a new, let's say, IoT vendor to your list by creating new rules for the whitelist. And again, in the lab section, we'll go through it and you will see how easy and user-friendly it is, the process is. And beginner engineer friendly. Again, it's based on the solutions with widely available documentation. On the Pi-hole website, there are great documentation. For Juniper products, there are great documentation, there are great resources, educational resources available, which we'll cover in the one of the next videos. And upcoming lab demo, which we'll be doing in video 2, will be a great contribution toward this goal. And the final thing which I would like to mention is that today in October 2024 we have a very nice option for you engineers out there. If you are located in the US, you can use this link. I will put this link in the description as well, but by going there you can get a MIST demo, and by attending and participating you can get a free MIST AP for yourself and access to MIST AI to get familiar with it, right? So I recommend you to go and have a look. Here we are. We concluded our theory block. So are you excited to get hands-on practice? Jump to the second video and I'll meet you there.